Hi, let's go over the exponential depreciation formula, and I have three examples. Number one, the historical prices of a car are recorded for 11 years as shown. Determine the exponential depreciation equation that models this data, round to the nearest hundreds. And part B, determine the depreciation rate. To understand the formula, we need to write it down first, which is f of x or y equal a times, which is the initial amount, times 1 minus r. R is the depreciation rate for part B, to the power x. Or differently, y equal a times b to the power x. Now, to do that, we need a calculator to find the depreciation equation. And here we go. Let's turn it on. You go under stats. Stats is right here. And it shows you are in the mode of edit. So it's ready to enter the data. Enter. If there is numbers right here, for example, like this, and like this, and more, you need to delete them first by going with the arrows up all the way and hit clear and enter. Same thing for L1, clear and enter. Now let's enter the numbers and speed up the process so I could get back to you. Make sure that you have the same numbers or number of data entered in L2 and L1 are aligned. If you enter 10 numbers right here or 11 numbers right here and 7 right here, when you start calculating, it's going to say data mismatch because you don't have the same amount of numbers on the left and the right, or X1 and X2 or whatever. So you have to have the same amount. I've seen some students, they stop right here, for example, by mistake. So 1 is blank, aligned, let's say, with number 10, and they can't go through because it says data mismatch. Now, after you enter the data, we need to go to Stat, Calculate, and let's go down all the way to after 9, you'll see 0. Which says exponential regression. Hit enter, and it shows that I'm reading from L1 and L2, and let's calculate. So we have y equals a times b to the x, where a is 17. 895.9718 and b is 0.885381731. Let's write them down. Take the calculator to the side and write them down. So I have a equals 17 895.9718. Let's move the paper a little bit. And we have b equals 0.885381731. So the equation becomes y equal 17 895.97 multiplied by 0.89. If you round this right here, that's 0.89 to 2 digits to the power x. That is part A. Now part B, says determine the depreciation rate. Well, the depreciation rate is R. We have B equals 1 minus R. That's from here. That's B. And that's Y minus R. If you switch B and R, we get R equals 1 minus B, or the difference. And that is 1 minus 0.89 when we rounded the base B, which is 0.89, and that will give me about 11 or 11%. That is the depreciation rate. So the car prices are depreciating with 11% every year for 11 years. Now, we could also do the following. We could write these numbers inside the Y, which is, you know what, let me wait for Y1 and go and graph the table in the stats mode as a scatter plot. Let's go to stat, and we know the data right here. That's what we have. Let's go to zoom right here and go to zoom stat, which is number 9. Zoom stat will adjust the window to do it. Since it's not graphing anything, I have to go to stat plots right there, second stat plot, since it's blue, and we need to turn one of them on. Everything is off. That's why I didn't see the graph. So let's turn the first one on. Here we go. Now it's on. I'm doing a scatter plot from L1 and L2, and let's see it as small boxes instead of this tiny dot, or this tiny dot. Here we go. Graph. Still it's not showing. So let's go to the right mode and zoom. Go to zoom and zoom stat, which is number 9. Enter. Now you see it. These are the numbers that are coming from this table. 0, 19,000, that's this one right here. And the last one is right here, which is 10, 5,600. Let's take the Y function that we found and put it in Y1. So we have 17,895.97 multiplied by 0.89 to the power x. And to raise it to the power x, you need to use this right here and this key that shows x values. Let's go back to graph and see what we're gonna have. This is the equation that we have. Of course, we use this for predictions. Like, let's say I want to see the value of the car after 15 years. I could use this to evaluate. Okay, that's a lot of ways. It's not on the exam, but you could do that under table and enter your own numbers to evaluate. Okay, after 5 years, after 10 years, and so on. Let's go for 10 years. 10 years is 5580.3. So this is our data, but this is from the line or the curve that we found that represents this data as exponential depreciation. That's the equation that we have. That is number 1. Let's go to number 2. Number 2. The car that Diana bought is 8 years old. She paid $6,700. This make and model depreciates exponentially at a rate of 14.15% per year. What was the original price of the car when it was new? So we have 14.15% 15%. That's called the depreciation rate. And we know that we have 8 years, the age of the car, and she paid this much. We need to know what was the original price. To do that, we're going to use the formula y equals a times b to the x, but let's find b first. R is 14.15%. As a decimal, R equals 0.1415 by dividing by 100 or by moving the decimal to the left. So b is 1 minus r, which is 1 minus 0.1415, and that is equal to 0.8585. Therefore, we have y equal a times b to the x, which is a, or the initial amount, the initial value of the car, times b, which is 0.8585 to the power x, or t in this case. Since we're looking at number of years, in this case x is t as time, number of years. So I'm going to write 8 here instead of writing t to save you some time. The value now is 6,700. We need to find a, the initial price. What was the original price? That's my a. Original price is a, question mark. To do that, I could divide both sides by this number, 0.8585 to the power 8, 0.8585 to the power 8. That cancels from the right side. We end up with a by itself is equal to, let me write it on the left so I could use the calculator to the right. A will equal to 6,700 divided by 0.8585 raised to the power 8. If you find this value on the side and round it, you're not going to get the accurate answer. So we need to wait and finish the calculations, and then we'll round our answer. Let's use the calculator. Here we go. So we have 6,700 divided by, open parentheses, 0.8585 raised to the power, and that's how you raise it to the power, right here, and the number 8. Enter, and that shows 22. Let's move the paper a little bit. 22,706.6155. But that number, since it's money, it should be rounded to about 22,706.615 will be 62. And that should do it. That is number 2. Number 3. Laura's new car cost her $21,000. She was told that this make and model depreciates exponentially at a rate of 8 and 5/8 or 5/8 per year. How much will her car be worth after 100 months? So I have a few things. The depreciation exponential rate is 8 and 5/8. That is R equals 8 and 5/8. How to type this on the calculator? That's one way to do it. So I need to change the 5/8 to decimal, which is 0.625. Since it's exact, it's not rounded, I could write this as 8 and 5/8, which is 0.625. To write this as a decimal, that's percent, I could write this as a decimal by doing the following. Divide by 100 or move the decimal to the left 2 places, becomes 0.08625. That's my depreciation rate. Secondly, we have 100 months, but that's not in years. We need to divide 100 by 12. That's how many months in a year. That will give me 100 divided by 12. As you could see, it's 8.3 repeating, but we need to write accurate numbers. We don't want to round. The best way to do the math is keep everything accurate, round your answer, the final answer. So what I mean by this, that's 8 and 1/3. So 1/3 gives me the 0.3 repeating, as you can see. So, or differently, I could multiply 3 times 8 and add 1. That's times 3 times 8 is 24, plus 1 is 25. As you could see, dividing 25 by 3, that will give me 8, because 8 times 3 is 24, and the remainder of 1. That is the same as 8.3 repeating. Okay? So that should be the number of years. That's T. Going back to the problem, we have y equal a times 1 minus r to the power t, which is the following. 21,000 for a from here, times 1 minus r, 1 minus 0.08625 to the power t, and t is the accurate number, is 25 over 3. That is 25 over 3 equals 21,000 times 1 minus r. I could do that on the calculator, and I'll type it after. 1 minus 0.08625 is 0.91375. 0.91375 to the power 25 over 3. Let's calculate that on the calculator. Let's clear this and look at the empty screen. We have 21,000, 1, 2, 3, open parentheses, type 0.91375, raise it to the power. That's how you raise it. One more time, to the power. And we need to type the 25 over 3. So I'm going to use another parenthesis just to be on the safe side, and enter. I have from the calculator 9903.321492. But since this is going to be price or money, we need to round to 2 digits, which is approximate to 9903. That is $9,903.32, because 1 is lower than 5, so we're gonna drop this down. 32. How much will her car be worth after 100 months? Starting at 21,000, the car will be valued as $9,903.32. And that should do it.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.